Do you know how to deal with vectors questions when we're trying to prove that they're parallel or lying on a straight line? This is the easier part of the vectors topic, so definitely make sure you know how to do it. ABCD is a parallelogram, M is the midpoint of CD, as we can see, N is a point on AC such that ANNC is 2 to 1. So I'm going to write that there, but those are not the vectors, that's just the scale. AB is given as 4A, so let's write that on, and AD is given as 4B. Show that BNM lie on a straight line. So I'm going to draw that first. To prove that anything lies on a straight line, we first need to prove that two of the vectors are parallel. So you choose any two vectors from this line. I'm going to choose BM as a whole, because I think that's the easiest one to do. To work out BM, I would like to go BC and then CM. We've got a parallelogram, which means that BC is also 4B and that DC in that direction is 4A. So I've got 4B now, not plus because I'm going the wrong direction. It's actually minus. And then half of that, M is the midpoint, so half of 4A is 2A. So I've got BM as a whole. Now I'm going to choose one of the smaller ones, either BN or NM. To go from B to N, I want B to A to N. So I need to know the whole of AC, first of all. A to C would be 4B plus 4A. Now we need to share out this ratio to get just A to N. We need to convert the ratio into fractions. So 2 on this side is 2/3 because if you add them together, you get 3, and then the 1 would be 1/3. I'm using AN, which is the side with 2/3. So it's 2/3 of AC. Now to use that to make BN. BN, I would probably go up to A, so that's negative 4A, because I'm going the wrong direction, plus 2/3 4B plus 4A. Now let's just expand and simplify all of that. Make sure you're happy with multiplying fractions and whole numbers for this topic, and adding fractions and whole numbers. Okay, so now we know BN, and let's rewrite BM with the A first. To prove that two vectors lie on a straight line, we first need to prove that they are parallel, which means showing that they are a multiple of each other. So I'm going to work out the scale between the A's and hope it's the same as the scale between the B's. So the scale between the A coefficients is 3/2, and the scale between the B coefficients is the same. Therefore, they are parallel. So I write it out to show that they're multiples, which therefore means parallel. To then show that they lie on a straight line, we have to say that there's a point in common. In this case, they both share the point B. Therefore, they lie on a straight line. That just proves that they're not two random vectors floating around, but they actually overlap each other because they start at the same point. If you found this helpful, make sure to check out the GCSE Maths Pro YouTube channel where you can find full videos going through everything that we've just seen.